Yeah, this is a traffic lights control system for urban intersections project presentation by Opifeni Manuel Derrick, Group 6. So, this is the introduction. Rapid urbanization has led to the increased traffic congestion in many developed cities, including Mbarara City. So, the person who will introduce this part will talk about this. We'll introduce that, then show the network design. Now, in the network design, this is we created a PNG image because we changed the background for packet tracer. We used Photoshop to create this road and then transferred it into the packet tracer to give us a network design for how our lights will be positioned in the network as a network diagram. So you see that we have the lights because we have the lights, we have RGB lights, we have the microcontrollers, the two microcontrollers, and then we have a camera, then we have a wireless router that connects to connects to a remote office, to another router which connects to the remote office, where we can control our IoT devices online or via the internet. Then we have the sensors there positioned on line 1, lane 3, and lane 2. So another person can talk about the device configuration, where we talk about the sensors and the actuators that we are using. Describe the actuators, which are the LED lights. So we have the 5 LED lights, 2 lights for pedestrians, 1 LED on to show the direction of traffic going the other way, joining another lane. Basically, the LEDs were used to join other lanes. Then the 3 RGBs were used for main lanes, which is red for stop, green, and then move. So we used the LEDs for routes that are joining other lanes, and then the 3 RGBs for the main lanes, traffic that is just using the main lanes, except for the south. Then we have the sensors. We use the 3 motion sensors. Then we use the cameras. Cameras, I think, actuators. Yeah, anyway, we used the 3 motion sensors. We used 3 cameras, and then we used the microcontrollers. Then we now come to the automation rule programming. We use them 2 microcontrollers, and then this is how we configured how, because now these are the pins on the microcontrollers, the MCUs. So this is how we are configured on the first MCU. The first MCU is this one. This is MCU1. So on MCU1, this is how we configured that on on a D0. On port 0, we put the motion sensor 1. On D1, we put 2. On D2, we put sensor 3. Then on D3, we connected it to the MCU2. On D3 in MCU1, we connected it to D0, 0 on MCU2. Then D1, 1 on D4, we connected it to D1 on the other second microcontroller. And D5 we then connected it to D2 on the second microcontroller. So activities on the first microcontroller are going to affect activities in the second microcontroller. So the first MCU was controlling the second MCU through D3, D4, D5. Then we have then we connected we only used the green and red for the RGBs. We didn't use blue because the pins, the number of pins. So A0, we used the analog ports A0, A1 for line 2 and A2, A3 for lane 1. So now you notice that we use the second MCU for lane 3, that is D3, D4, and then the other lights, the 5 lights, we used from D5 and then to A3. The lane on 3 right, the turning on lane 3, turning to the right, on lane 1 turning to the right, and then on lane 2 turning to the left, then the 2 for pedestrians. So that is how the microcontrollers were working and how they are connected to the light. So we can see the 3 sensors and the two RGBs on lane 1 and lane 2 were connected to this microcontroller. Then these other lights, all the other LED lights were connected to the second microcontroller. So this now explains the configuration of the microcontroller, how it was works as the main. So we have to understand how traffic basically was flowing, and the MCU works as the main microcontroller. It captured all the motion sensor inputs from the pins, and then MC2 depended on the inputs from MC1 to control the light on lane 3 and the other 5 lights. So that is what is being explained here, the microcontroller too. So, and this is now the traffic lights were working in phases. So in the phase 1, MCU1, also MCU2 had a phase 1 because MCU2 was depending on MCU1. So in phase 1 of the MCU, we know that traffic was moving on lane 1 and lane 2. By traffic moving from lane 1, I called it west traffic. It's like from the junction, if we were to imagine the Chizungu junction, as you're coming from Kampala or as you're going to after Ajip there, you see that lane 1, there are cars going straight. So, and then in lane 2, there are cars that are coming from Kampala to Mbarara or branching off through to Chizungu. So these lights, now if there are cars coming from Mbarara to Kampala, and then there are cars coming from Kampala to Mbarara, from lane 2 going into Mbarara, you lay cars from Mbarara that would want to branch off to the right into lane 4 wouldn't be allowed. They would have to wait for the lights to stop them. So we shall see now. This is how this phase 1 logic works. Where phase 1 logic, the green for lane 1 straight, according to how we program the lights, we have to give them a digital right, which is A1, which is high or low. So if it is green, if we want green to light, we'll make it high. If we want red to light, we'll make red high. But in this case, phase 1 is assuming traffic is on lane 1 and lane 2. So A1 will be green. A1 will be traffic on lane 1 will be green, and also traffic on lane 2 will be green. And then no turning right from lane 1 to lane 4 is this one, meaning that this west 1B is not going to be lighting. Why? Because no one is supposed to be turning. And green on for turning left from lane 2, and then no turning right from lane 3. Now as traffic is moving from lane 1 like from Mbarara to Kampala and from Kampala to Mbarara, only that traffic is going to be allowed, and maybe those ones that are branching off from Kampala to Chizungu. Meanwhile, those from Chizungu are not being allowed. Those from Chizungu who want to enter the main road are not being allowed. Okay, and that is captured in phase 1 of MCU2 also, where we will see now that as cars are moving from lane 1 and then from lane 2, those there are those that are being allowed branch off to lane 4 and then continuing, then those who are at lane 1 and then continuing down sorry, and then going straight. So that is how the MC was programmed. Then in phase 2, we are going to give priority to moving cars moving from west to east, meaning from lane 1 from Mbarara maybe to Kampala, or from Mbarara to Chizungu. And then we control the lights to light like that, green still high, and the meaning red is off, because this is the RGB. So both these pins are connected to one light, even these two. Then now we see that here the green is off. We are now considering red. We have blocked traffic from Kampala to Mbarara, to allow traffic from Mbarara from lane 1 joining lane 4. Let me use the lanes. From lane 1 joining lane 4, and from lane 1 continuing on lane 1. We have to block traffic from lane 2 continuing on lane 2, or on lane 2 branching off to lane 4, to avoid collisions. And in this case, since this meaning that at this moment lane 2 will be blocked off, so we can allow lane 3 to join lane 2, but not to join lane 1. That's why its light is off. Its light here is off. Then we go to, that will be phase 2 now, and the MCUs represent the lights are controlled like that using the phases. Then the phase 3 is now when we are allowing traffic from Chizungu to joining the main road. That is phase 3. And in phase 3 we see we are allowing traffic from lane 3 to enter lane 2 and to enter lane 1, meaning that lane 1 will have to stop to allow traffic from lane 3 to enter, and also lane 2 will have to stop to allow lane 3 to enter lane 2. But since there is no one using lane 4 at that moment, lane 2 can use the traffic from lane 2 into lane 4 can be allowed. That will be the phase 3. And the MCU lights and the lights are controlled, are configured to show that. So this configuration is for these lights. Then when the pedestrians are crossing, we program all the lights to be to show red or off for, and then the pedestrian lights to light green, so that pedestrians are allowed to cross. Then the ambulance priority control, that one is used. We use the IoT, whereby if we use a remote IoT, the remote server, and the cameras. So here we see the cameras will be monitoring each lane. Cameras will be monitoring each lane. So as it's monitoring each lane, they'll be able to see ambulances on which lane the ambulance is on. So the person will be controlling the lanes from the server. You can go to the IoT. Where is the IoT monitor? IoT monitor. There's 172.0.0.2. Logging. So from the remote office here, you see we have connected to the traffic lights. So here we made the motion sensors smart devices to be able to connect to the server and then be accessed via the remote PC. So from here, if the ambulance was on lane 1, would come here and then force traffic on lane 1. Now we see that lane 1 traffic is being considered, so we just keep forcing it until the traffic is on lane 1 is moved. So if it was on lane 2, we would be turning on things from there. This is meant to just to view the camera, to view the office. So here I would be viewing the cameras from the office. You'll be viewing the lanes on lane 1, lane 2, and lane 3. Yeah, then when the code loops through all 4 phases until special event causes. So the connection to the IoT server in remote office location, we have one wireless router. This is how it was configured. That's how the DHCP was configured. The wireless router is here. The wireless router is this. So these are its configurations. Internet. I use the graphical user interface to configure it. Configured it with some security. We were using 2G, 2.4 gigahertz for wider coverage. Then gave it an SSID. The security. Yeah, and we gave it a password, a WPA2 password. That is only known by the devices. So that was the router. Then the IoT server setup. We did the server setup, connected it to this router, and then the router access the server here. So on the server, we had to turn on the IoT. Gave it an IoT, and then once it was on, we created the user account and gave it a username admin and password admin. That is the only service that was activated on the server. And then that is how from connecting to 172.0.0.2/home, we managed to access the remote the sensors and the cameras remotely. So that is how we set it up. The project was set up successfully, implementing on packet tracer with the use of 3 motion sensors, 3 cameras, 3 red lights, RGB LED lights, and 5 LED lights, and 2 MCU microcontrollers to create a functional traffic light system on a T-junction. And then this is the full code to automate the system, we use if statements. If there is no traffic on the west, east, and what, the phases will play through the microcontroller. If there is high traffic on all lanes, the phases will still play through with bit of delay time in the microcontroller. If there is high traffic on lane 1, that is on lane 1, then lane 1 will be considered first, phase 1 will be considered, and phase 2, and then pedestrians, phase 4, will be allowed to pass. If it is high on lane 2, only phase 1, which favors phase 2 lane 2 will be allowed to go forward. Then if it is on lane 3, then phase 3 will be allowed to, which favors lane 3 will go forward. Then there's the phase 1 logic, the phase 2 logic, the phase 3 logic, and phase 4. Also on the MCU2, we did similar setups, but since it was being controlled by MCU1, yeah, basically the logic was almost the same, and the phases were treated almost the same, with phase 1, phase 2, and phase 3. And that is it. Thank you for listening. So that is how the system is running, both using sensors and the IoT, being controlled from the IoT monitor. Yeah, so that is how it is working. Thank you.